Warm up for lesson 5-1. Pause to do the problem. And here's the answer. Pause to do the problem. And here's the answer. Pause to do the problem. And here's the answer. Pause to do the problem. And here's the answer. Lesson 5-1, Operations with Polynomials. Objective: multiply, divide, and simplify monomials and expressions involving powers. Add, subtract, and multiply polynomials. These are the properties of exponents. Let's take a look at the property. It's called product of powers, and let's look at this example. You can see all the bases are the same, and so what we do is we add the exponents. Quotient of powers. If the bases are the same, we subtract the numerator minus the denominator. Negative exponents. When we have a negative exponent, we turn it into a reciprocal of the positive exponent. So 3 to the negative fifth can be written as the reciprocal 1 over 3 to the fifth power, positive fifth power. And this can happen as well. If the negative exponent's in the denominator, then its reciprocal will be b to the positive seventh power. Power of a power, you can multiply the two powers as long as the base is the same. Power of a product, right here, then each one of these factors has the same product. So 2k to the fourth power, 2 will go to the fourth power, k will go to the fourth power. Power of a quotient, again, the quotient, each of the numerator will go to that power, the denominator will go to that power, just like over in this example. And the zero power. A base to the zero power is equal to 1, as long as the base is not 1. All right, monomials. What's a monomial? Well, a monomial has no powers of powers. That's a simplified form. Each base appears exactly once. All fractions are in simplest form, and there are no negative exponents. So let's take a look at this expression. It is not simplified. I can see there's negative exponents here, and I can see there's some repeating of a's, so we want to simplify it. So we're going to change these negative exponents into the reciprocals, 1 over a to the second, and this one, 1 over c to the second. And we can expand them, and when we expand them, we can see there's some simplifying that can occur. We gather them all up, and we're going to get 6ab to squared c squared. Now we know this is simplified because there's no repetition of powers, there's no negative exponents, and all fractions are simplified. All right, let's take a look at this example here. They are using the power rules, taking the numerator, subtracting the denominator power, numerator power, subtracting. Now, if this confuses you, you can always expand q times q, r to the fourth power, and you can reduce, and you'll get the same answer as we did over here. A power to a power, what you need to do is take each factor and take it to that power. Or you could do this, and you could just write it 3 times and then simplify from there. All right, let's do some examples. All right, the first step is I am going to eliminate all negative exponents, so that'll be x to the third times y to the third over 1 times negative 7 times x to the fifth over 1 times 1 over y to the sixth. Now this is 2 times y times y times y times a negative 7 times x times x is x times x times x all over x times x times x, and then we have 6y's being multiplied. Now if you don't need to do this, that's fine, but this is a nice way to make sure that you're understanding this idea. All right, and what we have left is, in the numerator we have a negative 14x squared, and the denominator we have I to the third. Notice we aren't repeating any variables, and we have reduced. All right, let's go ahead and do this problem. And this is going to be equal to 3 times 5, and we have 5 c's being multiplied and 3 d's being multiplied. All right, there's 3 here. That will reduce with 3 here. So I'm going to have 4 d's in the denominator. And then I can reduce some c's, and I can reduce some constants here. So my answer is going to be 5 c to the 3rd power. I'm going to have a negative, so I'll put it right here. And then this will be d to the 4th power. Now remember, this is a negative exponent, and that's going to be the reciprocal to the positive power. And then I'm going to do 4 times 4 times 4. That's 3 times, and a times a times a. So this is going to be 64 over a to the 3rd power. Over here, this means negative 2x to the 3rd, y to the 2nd, and that's going to be 5 times. Now, you don't have to write it out. If you know your shortcut, you can go ahead and use it. But if you don't understand the shortcut, then this will always give you the right answer until you get comfortable. Okay, I can see I have 1, 2, 3, 4, 5 2's. So that's going to be a negative number, I know. That's going to be 32. And there's 3 here, 3 here, 3 here, 3 here, 3 here. So that's 15. And then again, that's going to be 10. And so that's the simplified version. Okay, stop the screencast to see what you can do. And here's the answers. All right, let's talk about the degree of a polynomial. The degree of the polynomial is the monomial with the greatest degree. So when we take a look at these two, first it is this is a monomial and this is a monomial. And if I add these powers here, that's going to be a 7. And this power is 5, so the greatest is 7, and we call this degree 7. Now this is not a polynomial because of that square root. And this is not a polynomial because of the negative exponent. Okay, so what is the degree of the polynomial? And this is not a polynomial, so we don't have to find the degree. Now here we have a 5 and a 1, so this term is 6. This term is 4 and 3, which is 7. This term has both one exponent, so that's 2. The greatest number is degree 7. Stop the screencast and try the problem. Here are the answers. All right, let's talk about simplifying a polynomial expression. This is a subtraction, and when you do a subtraction, we are going to distribute that negative sign to each term, and then we're going to add like terms together. Over here, we can eliminate the parentheses, and we can just add like terms, and you can do it vertically as well as horizontally. Okay, over here I'm going to do the problem. I'm going to eliminate the parentheses by multiplying by a -1 for all of these terms here. That's distributing. And then I'm going to collect like terms. And here's the answer. Over here, I can just disregard the parentheses because this is a plus sign, and I just add like terms. Okay, pause and see what you can do. And here's the answer. All right, let's talk about distributing, using the distributing property. And right here, what I've done is I've already started making sure I'm going to take this factor and multiply it to each one of the terms here. And I've already done that here. So now I'm ready to actually simplify this. And I can do a little simplifying with my fractions here. I'll do that now before I start multiplying. All right, and then my answer is going to be here. I have a 2 here and a 4 here, so that's 8x to the 4th power, plus I have a 4 here and a 3 here. I'm going to multiply. That's 12 x to the third power. A negative 4 and a 4, that's negative 16x squared. Okay, right here I'm doing the same thing. I multiplied to each one of these terms, and now I'm ready to multiply. A negative times a negative is positive a to the third. Negative times negative is positive 22a squared. Negative times positive is negative 40a. Pause and see what you can do. And here's the answer. Okay, let's take a look at applying by writing a polynomial expression. We have a truck driver, and he has to work a 10-hour shift. So some of these hours that he's going to drive are going to be, his first shift is at 60 miles an hour, and his second shift is at 10 miles an hour, at 70 miles an hour. So we're going to let x be his first shift, and so the number of miles he'll drive is 60 times x. Now the leftover from 10 will be 10 minus x, and the remainder of his shift will be at 70 miles an hour. So it's this expression, and if you distribute, we're going to get this, we're going to add like terms, and that will be the polynomial that it represents. Pause, see what you can do, and here's the answer. Let's take a look at multiplying polynomials. When we multiply polynomials, what we're going to do is we're going to take this term and we're going to multiply it to that whole binomial, and then we're going to do the same thing here, multiply it to the whole binomial, and here, and take it to the whole binomial, and that's what's happening. Each term gets multiplied to the whole binomial, and then we distribute again. So let's take a look at that, what that would look like. I'm going to take this, and I'm going to multiply it to the whole term, this, multiply it to the whole term, multiply this to the whole term. Then it's going to look like this: x squared times x minus 4 plus 4x times x minus 4 plus 16 times x minus 4. Now I have to do some more distributing. X to the third minus 4x squared plus 4x squared minus 16x plus 16x minus 64. Now I'm going to add like terms. X cubed. Looks like the x terms are, x squared terms are going to cancel. Looks like the x terms are going to cancel, and then that'll be this. We're going to skip 6b, pause and see what you can do, and here is the answer.